Hello, Math 2318 students. A question came in on my math lab question, section 4.2.1. Determine if W equal to 541 is in the null space of A, where A looks like this. Okay, so just thought I'd review. That will help with a lot of review from a pre-spring break material. So the answer is for A, a 3 by 3, which is associated with the transformation from R3 to R3 that takes a vector x and multiplies it by ax a on the left. For a vector in R3 to be in the null space, well, go back and remember what the definition is of that, where null space is the same thing as the kernel of the associated transformation, right? And so that means the set of all vectors in the domain space that get mapped to 0 by the transformation. What is the transformation? It takes a vector, multiplies on the left by a. So it's a set of all vectors that solve AV equal to 0. Set of all vectors V that do that. So to figure out whether that particular vector belongs to it, we could have actually just multiplied A by W and see if we get 0. I realize now. But I guess I was looking for, let's review, and so I suppose the question was a little bit bigger, like find the null space of this matrix. Well, then we need to solve AX equal to 0, right? Or solve that associated augmented matrix. And notice, recall again that X is some generic vector from R3 with, let's say, coordinates X, Y, and Z. So using RREF, which you have available to you on the graphing calculators, you would solve this and you get an answer like this. And I assume that the reason this was a question was that the student didn't either remember the definition of a null space or didn't maybe know how to interpret that when they got to this point. So that's why it's good to remind yourself where the original input to using RREF came from. Trying to solve AX equal to 0 is the same thing as solving this matrix equation. If you spell out what the vector X looks like, that gives you a context for interpreting results like this one. So that augmented matrix is the same as this. And that is the same, this matrix equation is the same as this system of equations. So remember, you want to be able to go from vector equation to matrix equation to systems of equation at will when necessary. If you multiply that out, you get this. And notice there's no constraints on Z. So Z is arbitrary. So taking it up here, because we need more space. Right, we get this. That, therefore, X is equal to 5 of the Z's, Y is 4 of the Z's, and Z can be any arbitrary real number T. Now, the question was, does 541 belong to the vector space? Well, that means, can you write the solution to this system with a choice of T that gives you 541? Well, Z is going to be equal to T, so choose Z equal to 1. Then Y will equal to 4 and X will equal to 5. So yes, long answer is it's in the null space because we found the whole entire thing and then checked that that particular vector was in there. Again, the short answer could have been to determine if this is in the null space. Once you redo the definition of what null space is, you could have at this point said, oh, if I take A and multiply it by W, do I get the 0 vector?